All right, today we are going to go over the third section of Unit 12, finding the roots of complex numbers. And we're going to find those roots of complex numbers when they're given to us in polar form. So just a really quick reminder here, a complex number in polar form is a little bit different than a complex number in rectangular form. Polar form of a complex number is going to look something like this. Typically, we call it Z or some single letter like that, later number letters in the alphabet. And then we put R at the beginning. That's the magnitude or the modulus of the particular complex number. And then we multiply that by the cosine of theta for that particular angle, for that particular number. That's why it's a polar coordinate, because it has an angle theta. Plus there's the I for the complex numbers, and then the sine of theta as well. So today we're going to talk about how we're going to use de Moivre's theorem, like we did in the last section, to be able to figure out a complex root based on the fact that you know that if you take a number to a power and get an answer, like for example, if I took 4 and I squared it and I got 16, that means that 4 is a root, a second root of 16. Okay, so we'd say 4 is a second or square root of 16. So that's basically what we are doing, is figuring out a number that could work out to take something to a power to equal something else. So it's called the complex nth root of W. Z is the complex nth root of W. And keeping in mind what we've done before, Z squared, those would be the complex square roots, and then Z cubed would be the complex cube roots. So we're going to basically use de Moivre's theorem, and this is the way that we'll figure out what the complex roots are. So if W is a complex number in polar form, just like I just said a minute ago, and we're going to use theta 0 for the angle measure, W is the complex number, then that complex number has n distinct complex nth roots. Okay, so if you're finding square roots, there's 2. If you're finding cube roots, there's 3. If you're finding 10th roots, there's 10 of them. And those roots are given by this formula right there. So we're going to practice kind of using this formula. And you'll notice a couple things that we've done before. Nth root, of course, and then also 2k pi. That's basically how we find angles as you go around a circle that result in the same, basically they're coterminal when you have 2 pi times a number k, assuming k is, of course, an integer. Okay. Other than that, this looks an awful lot like de Moivre's theorem. Okay, so let's go ahead and use this formula to figure out the complex roots of a particular complex number. So if that complex number is -1 plus the square root of 3i, we are going to go ahead then and leave our answer in polar form. And we'll use degrees because I think that'll be a little bit easier. So step 1 is to go ahead and express this number in its polar form with cosine and sine, with r and with theta. So we're going to do that first. We're going to say the polar form of this particular number is going to be based on the fact that, here, let me do it this way first. This first, we're going to say -1 plus the square root of 3i is equal to, first thing I'm going to do is I'm going to factor out a number that's going to become the r value. That's going to go out front just like that. Now, to figure out what that r value is, I'm going to go ahead and do this. This is the formula to figure out the modulus. You take the square root of the first number, x, or a, I guess you could say, that's squared, plus the square root, or that number squared, the square root of 3 squared. Just like that. Okay, so that's going to be the square root of 1 plus 3, which is, of course, the square root of 4. So the r value is going to be 2. So once we figure out what r is, we're going to put that right here. And if that's a 2, how would you get a -1? You would have to multiply it by a -1/2. There we go. There is going to be an I. And then you'd also have to multiply it by the square root of 3 over 2. So those numbers should look kind of familiar as we think about what this number is going to look like. So -1/2 and square root of 3 over 2 are going to be the cosine and sine of our number. If you go back up to here, when we did the polar form of a complex number. So we're going to say that's the cosine of theta, and that is the sine of theta. So if you want an angle that has that cosine and that sine, let's go back to something that we did a while ago. Let's do this. You're basically solving an equation. So I would do this, and if your cosine's negative and your sine is positive, then you must be in quadrant 2, and that would look something like this. Cosine is to the left, sine is going to be up, so we're going to say that's -1/2. That's the square root of 3/2. So therefore, theta, our angle measure, is going to have to be, 30 degrees past 90. So we're going to go ahead and use 120 degrees. All right, so now we have our polar form of our number, and it's going to look just like this. 2 times the cosine of 120 degrees plus I times the sine of 120 degrees. Great. So now that we have that right there, that's the first thing we do. Now we can go back up here and look at the formula, which is based on de Moivre's, that will help us find all 3 of the cube roots. So don't forget, there are going to have to be 3 of them, okay? Cube roots, okay, we have to find 3 answers, basically, or 3 solutions, 3 cube roots, okay? There's always going to be that number based on how many roots you have. All right, so now let's go ahead and do this. Okay, so based on what de Moivre's says, let's go ahead and figure out what the cube roots would be. So first things first, I'm going to go ahead and use k. So based on this formula, I'm going to go out here now. Okay, so based on this formula, along with that complex number, I'm going to go ahead and say zk, just to kind of be consistent with the way the formula works. So these are the roots of the complex number z, assuming that that is our complex number z. So the roots of the complex number z are going to be based upon, actually, yeah, that would make sense, I think. Okay, so the roots are going to be based upon taking the cube root of r, that's the cube root of 2, and I'm going to take the cosine of 120, and I'm going to divide that by 3 because we're doing the cube root. So the angle measure gets divided by 3. And I'm going to do plus, instead of 2 pi and k, I'm going to do 360k. So that's going to look like this. 360 degrees times k, also over 3. And then I'm going to do pretty much the exact same thing, but with sine. Okay, here I'm kind of running out of space here. Let me try this again. All right, I'm going to close this out. If I need the calculator, I will get it back in just a minute. All right, so now I'm going to add to that the I, and then that's going to be multiplied by the sine of, and I'm going to do pretty much a direct copy of what I did with cosine. 120 over 3 plus 360k. Okay, try that again. Over 3. Just like that. So that says 360k over 3 right there. All right, so now let me clean this up just a little bit, and then we'll figure out the different values for the cube root based on different values of k. All right, so the cube root of 2, I'm just going to leave that as is. We'll figure out that in just a moment. This would be the cosine of 120 over 3, that's 40. 360 over 3 is going to be 120, and there's a k there. 120 degrees times k plus I times the sine of, and again, I'm going to pretty much duplicate the same thing there. 40 degrees plus 120k degrees, like that. All right, so that kind of gives me my template, the way that I will figure out what that looks like to find the cube roots of that number. So if I want the cube roots of this number, and I should be able to double check this in my calculator here in just a minute when I'm done. So now I'm going to basically go through 3 different values of k because I need 3 different answers, right? Like we talked about before, 3 cube roots. So now I'm going to do k can equal either I'm going to start at 0 and go 1 and 2. Okay, so 0 for k, that means you don't have any extra k or 360 or 2 pi. 1 for k, and then 2 for k, just like this. So let's start off with k is equal to 0. So that would look something like this. We'll do z sub 0. That means it's the first cube root that we'll find. All right, so that's going to be the cube root of 2 times the cosine of 40 degrees. We'll need our calculator for that. That's not an exact value. Plus 120 degrees times 0, which is actually going to be just 120, just 0 degrees, I'm sorry. So here I'll do that, times 0, plus, and then one more time I'm going to duplicate. So you notice a pattern here. We just continuously duplicate the angle that we're taking cosine and then I sine of down here. So 40 degrees plus 120 degrees times 0. All right, so now I will need my calculator at this point. So give me just a moment, and I'm going to get that up for you. Okay, I'll go back. I know you can't see much there, but I'm basically going to make sure that I'm in degree mode. You can always switch to radians anytime you want, but I think it's easier to start in degrees. And I'm just going to do the cosine of 40. Actually, you know what? Here's what I'm going to do. I'm going to go ahead and just type this in exactly as it is written. I'm going to do the cube root, math 4 of 2 times the cosine of 40 degrees, because 120 is times 0, plus I, that's second I, times the sine of 40 degrees also. Now, I do need to put all this in parentheses. So the cube root of 2 there, and then I need to insert a parentheses there and another one at the very end, okay? So when all is said and done, I should get that number right there. 0.965 plus 0.810i, okay? So that's going to be my first complex root that I would get based on that number. So approximately 0.965. Okay. And as it said, the example in the directions, it did say that we were trying to put that answer, they wanted you to leave that answer in, hold on a second here, polar form in degrees. So basically, what that means is you can pretty much just leave it like that last answer, okay? So here, I'm going to back up and then I'll explain to you what I just said. So that's going to be 0.810. Okay, so I'm not going to figure out the decimal equivalent for all of these, not right now at least. 0.81i. All right, so that would be an approximate form, but you'll notice that it did say leave your answers in polar form. So the answer in polar form is going to look like this. This is going to be our first cube root, and it's just going to be the cube root of 2 cosine of 40 plus I sine of 40. So it's going to just look like this. Okay, so that's the best result that we're going to get as far as that goes. So that's going to be our first cube root just like that. All right, let me get rid of the calculator now. There we go. And there. All right. So now to find the other cube roots, you're basically going to just copy down exactly the same thing, but you're just going to change the value for k. So when you change the value for k, first of all, when k is equal to 1, okay, so that's going to be the cube root of 2 times the cosine of, and now you're going to do 40 degrees plus 1 times 120. Okay, plus I times the sine of, Same exact angle as we did with cosine. 40 degrees plus 1 times 120. So if you see a shortcut at this point and you want to not do all this work, that's totally fine. It's going to kind of end up looking pretty much the same. So here comes my next cube root. For this particular number, it's going to be the cube root of 2. It's going to be times the cosine of, and then 40 and 120, that's 160, plus I times the sine of 160 also, just like that. So that's my second cube root, okay? And then the third cube root is going to be based on the same thing. Notice the pattern here. We went from 40 to 160. So the next one is actually going to go up to 280. So we can kind of look at that as a pattern if you want to on that as well. So the last cube root then, our final piece of our answer here is going to look like this. Second, Z2, 0, 1, and now 2. So we're going to do cube root of 2 times the cosine of, we're going to do 40 degrees plus 120 times 2 plus I sine 40 degrees plus 120 times 2. All right, so then our final result here, we'll go ahead and clean this all up. The third cube root and the final one that we need is the cube root of 2 times the cosine of 40 plus 240, which is 280. So it would be the cosine of 280 plus I times the sine of 280. Just like that. And that's going to be our third one. So our three answers are going to be there, there, and there. Those are the three cube roots. So if you wanted to find square roots, you'd have to do it twice. If you want to find fourth root, you'd have to do it 4 times. Whatever number of roots you need to find, that's what you would have to be able to do. So that's kind of the idea, and that's what it would look like. All right, so now notice that a couple different things here. Each of them has the same magnitude. And also, each of them is going to be on the graph exactly 120 degrees apart from the other ones. So those would be the two things that I definitely would like you to make sure that you recognize on these. All three have the same magnitude, and that's going to be the cube root of 3. And that means they all would lie the same distance away from the origin. Sorry, it would be the cube root of 2 is what I meant to say. And also, you'll notice that they are also going to be 120 degrees apart. So if you were to graph them on the circle, I'll draw a little picture here like this, okay? You would see, notice, let's do, okay, so 40 degrees, and then the cube root of 2 is the length, so we'll go ahead and do this. Let's say that's 40 degrees, cube root of 2, okay? And then if you went to, what's the next one? 160 degrees. So 160 degrees would be right about here. Same distance away from the origin. Cube root of 2 and 160. And then the last one would be at 280, which would be right about there. And so that would be the cube root of 2 and 280 degrees, okay? So you'll notice that they are all spaced out nice and evenly, 120 degrees apart for each one, like that, around the circle. So if you had square roots, they would be 180 degrees apart. If you had fourth roots, they would be whatever a fourth of 360 is. They're always going to be spaced out that way if you were to draw them. Okay, these are not coincidental results. They are going to be that distance apart, 360 divided by 3. Just like that. All right, right, so here is that picture I was just talking about right there. This kind of gives you a better idea of the cube roots of that particular number that we just talked about, and the way it's always going to look when you think of it on the graph. Okay, so let's go ahead and do this. We'll make it as simple as we possibly can. Let me just go through a couple other examples here. So if you want complex fourth roots, don't forget that means we want 4 answers total on this particular problem. 4 answers, because we're looking for the complex fourth roots of that particular number. So the first thing that we're going to have to do is we're going to have to change that to polar form, which means we have to have r and we have to have theta. So to get r, we are going to do the square root of the square root of 3 squared minus 1 squared. So that's going to be the square root of 3 squared is 3 minus 1 squared. That's going to be 1. So that's going to be the square root of 2. So that's our r value. So then we're going to write our polar form like this. I'll call it z. R goes here. And then we're going to need to get 2 numbers that would go here and here. One of them is going to have an I with them. So in order to get the square root of 3, we're going to have to put a number that looks like this. It's going to be the square root of 3 over the square root of 2. Okay, and then this one would have to be 1 over the square root of 2. Oh, let me back up real quick here. Sorry, I'm going to erase that and start again. All right, so this should have been plus, which would mean that that would be the square root of 3 squared plus 1 squared, so it would actually become the square root of 4, which means it should actually be a 2 for my r value. There we go. So here comes polar form. 2 out front. And then if I need to get the square root of 3, I'm going to have to do the square root of 3 over 2, which is a nice exact cosine or sine value I can get, plus, actually in this case it would be minus, and then to get 1, I times 1, I would end up having to do 1/2, just like that. Okay, so now I need to think about on a circle, if that's a cosine of theta and that's my sine of theta, I'll draw a little picture here and we'll figure out what that angle is so we can get our polar form. We have r is 2, we have sine and cosine. So the cosine is positive and the sine is negative. So that would put us in quadrant 4. So that would mean we are square root of 3 over 2 to the right and 1/2 down. So that particular angle, we know what that would be, I think. That would end up being 30 degrees away from 360. So we're going to go ahead and say that that's 330 degrees. All right, so here's my polar form of z, and then I'm ready to go ahead and find any number of roots that I would want. So you got a 2, and you're going to have the cosine of 330 plus I times the sine of 330, and that's the number that we are looking for. So that's a polar form that would be exactly the same as that, which is in rectangular form. Okay, so now if we're going to find all 4 of the fourth roots, we'll find the first one, and then hopefully you'll kind of see a pattern, so it gets a little bit easier to be able to recognize what that would be. All right, so first we'll start with a 0. Okay, so I'm going to go ahead and do the fourth root of r. So that's going to look like this, fourth root of 2. And I'm going to do the cosine of 330 plus 0 360s over, I'm sorry, that would have to be over 4 because that's the root that I'm talking about. So I'm just going to do cosine of 330 degrees over 4 plus I times the sine of 330 degrees over 4. Okay, so my first fourth root of this particular number is going to look like this. And I'm going to leave it in this form because it's good enough at this point. So I'm going to take what's 330 divided by 4. It's 82.5. Plus I times the sine of, again, 82.5 degrees. So that right there is my first fourth root of that particular complex number. Now I'm going to do the next fourth root, and that's going to be z of 1. So I'm going to do the exact same thing. Whoops, the fourth root of 2. I'm going to take the cosine of, now I'm going to take 330 divided by 4, and I'm going to add on to that. So the 330 divided by 4 that I already did, 82.5, and I'm going to add on to that 360 divided by 4. Okay, and I'll figure out what that angle is here in just a minute. Okay, so I'm just going to clean this up, the 82.5 and then 360 divided by 4, and get my next fourth root, and that's going to look like this. 82.5 Need my calculator here for a moment. Okay, so I'm going to do 82.5 plus 360 over 4. And that's going to give me 172.5. And that's the angle measure that I'm going to use. So that's 120.5. So it's going to be cosine of 172.5 degrees plus I sine of 172.5 degrees. Now, I'm going to go ahead and use a little bit of a shortcut to get the other ones, okay? So what I want you to notice is that all these angles, these answers all look the same. The only difference is that we're going from 82.5 degrees to the next one is 172.5 degrees. Okay, so if you think about the difference in those angle measures there, here, I'll get this out of the way for you. 82.5 and 172.5, the difference is the same as 360 divided by 4. And that's going to be how we figure out the other answers. We don't really have to do all this work over and over and over again. So you're noticing it's 90 degrees, right? So we're going to just go ahead and take 172.5 plus 90. We'll get our next answer. A little bit of a shortcut here. You can definitely save yourself some time and mistakes. So I'm going to add 90 there. So the next angle I'm looking at is 262.5, and that's going to be right about there. And then one more time, plus 90. So notice whenever you have fourth roots, they're always going to be 90 degrees apart. So my last one will be really close to 360. It's going to be at 352.5 degrees. So here's my other two answers. 0, 1. Okay, this one, it's going to be the fourth root of 2 cosine of, and I'm going to do 262.5. Here I'm going to get rid of the calculator. There we go. Okay, and that's going to be 262.5 plus I times the sine of 262.5, like that. And then my final answer, my fourth root, is going to be this. Cosine of 352.5 degrees plus I sine of 352.5 degrees. There we go. So there we have 1, 2, 3, and 4 cube roots there. Okay. So I'm happy to go through more of these examples, or I think there's another page in the PDF notes that I provided for you. So we can definitely do that if you would like. But again, you can kind of think of that and look at the pattern as you would do that.